We're going to take a look at numbers 18 to 22 on activity 112, Simple Machines Practice, and this is all dealing with the inclined plane. So in this scenario, we have a civil engineer that must design a wheelchair-accessible ramp next to a set of steps leading up to a building. The height from the ground to the top of the stairs is 2 feet. Based on ADA codes, ADA is also known as the Americans with Disabilities Act, and they specify that the slope has to be 1 to 12 or less. So that would mean, in our scenario, we would want to, however many units you have, 12 units that you travel horizontally, you cannot rise more than 1 unit over the course of that 12 units that you have there. So slope is equal to the rise of the ramp divided by the run of the ramp, and they want us to sketch and annotate the inclined plane that is described above. So this one here is going to look very similar to just a regular inclined plane that we may have. We know that we have a height of 2 feet being noted here, and that we know the slope is a 1 to 12 in this scenario. It's really about all that we can go through and have right now at this point, but there's some pieces of information later on, things like the base, what is the length of the base of the ramp, and then also what is the length of our incline surface that we have going on as well, which is going to lead us into numbers 19, 20, 21, and 22. So looking at number 19, using the ADA code, what is the length of the ramp base? So again, just kind of looking at our sketch, what we're going to be looking for here is we're looking for this base component, not the slope surface. So we're looking for what is the length of that base. So here, what we can do is, utilizing the slope, our formula here will be slope is equal to rise over run. So as I take a look, I can set up a proportion looking at, all right, I've got a 1 to 12 slope, and so because I can rise 1 unit for every 12 units of run, and then as I take a look at this, I can see that my rise for this scenario is 2 feet, but I'm looking for how much run that I have. So this becomes just a cross multiply divide scenario where my run will end up being 12 times 2, and run times 1 would give us just whatever it is. So we end up having 24, and I'm going to have to express this with the same number of significant figures. So the 2-foot measurement that was given, they don't just give us one significant figure with the 2, they specify 3 significant figures. The 2, the 0, and the 0 are specified as how many significant figures we want. In this answer, we would have 1, 2, 3 significant figures, and that's what we want to express our answer as. In number 20, they will say, now that we know the height and the calculated base length, so now that as we kind of take a look here, our base is 24 feet. Now they say, what's this side of our incline? I'm going to go ahead and label this as C, because as a lot of us can see, a right triangle, this allows us to use Pythagorean Theorem. We know 2 of the sides, and we're able to solve for the third one. So our formula, a squared plus b squared equals c squared. And I'm going to go ahead and set this up here. 2 feet squared plus 24 feet squared is equal to c squared. And in order to get c by itself, I got to take the square root, which will make this cancel. But I have to go through and also include that in the calculation. So my calculator will end up being a huge benefit here as I go through and I take a look at being able to do that. Second, go through and have my square root. I'm going to add another parenthesis, so then that way I can put in 2 squared plus 24 squared, and then make sure to end out with the ending parenthesis for my square root symbol. So here I get this value as I go along. Same kind of scenario, I want to go to 3 significant figures, so the 24 will stay in there, and then I'm going to round off to the 10th place, and so I'm going to go ahead and round this to 24.1 feet for the length of my of my incline. So then it's going to ask, what is the ideal mechanical advantage of the ramp? So for my formula for the IMA for a ramp, I can see that that is length divided by height. So as I punch in the IMA, now here's the only thing is I notice how I didn't clear my calculator, is anytime you want to go through and have accurate values, you want to keep the raw answers in your calculator, not use like the rounded answer that we used up here on number 20. So I'm going to keep that raw answer, and then I'm going to go ahead and just hit divided by 2 to go ahead and do that for the height. And now I can go through and see that I've got a value of 12.04. So again, so I'm going to go ahead and see, we'll use 24.1 feet to our IMA is going to be, and again, if we're dealing with 3 significant figures, we can go ahead and have this expressed as 12.0 to 1. So that allows us to be able to see those types of things. All right, last one here, very similar to some of our pulley problems that we had earlier in our scenario, was that we went through and we had, and I'm going to write this over to the side, since we're ignoring friction loss, IMA and AMA are going to be equal to each other. The only difference between the two is counting in friction. So if we're ignoring friction, those are going to be the same thing. In this sense, it just becomes mechanical advantage. So they say they've got a wheelchair and a person with a combined weight of 185 pounds, and if we wanted to push them up the ramp, what is the ideal effort force we would need to do that? So I'm going to go ahead and use an AMA formula, because that has a resistance force and an effort force in there, and we're going to be looking for the effort force. Now, from our last answer, we went through and had a value of 12, so then that we can go ahead and utilize here. Notice how I've kept that answer in my calculator and not cleared it. So I'm going to use that raw answer, but when I write it down on my paper, I'm going to go ahead and keep it as 12.0. So I'm going to plug this in, the mechanical advantage in for the AMA, since they are equal to each other, since we're ignoring friction. And the resistance force is 185 pounds over the effort force. And then what I have to do here, I do have to be careful. So sometimes I see this trip some people up. If I multiply by the effort force on this side, I've got to on this side. And then in order to go through and to get, I'm going to kind of write this down here in the area below. In order to get FE by itself, I've got to divide by 12. So if I go ahead, I'm going to go ahead and run that value in my calculator, 185 divided by 12. And as I go through and run that, I'm going to get a value. Again, 3 significant figures. You can see that from the weight there, but also what we had provided in the previous significant figures answers. So here I'm going to end up getting an effort force of 15.4 pounds of effort force that I need to go through and have in order to push someone up the ramp to be able to make that happen. All right, so this finishes up the incline plane, and hopefully you can go through and see where we're going with a lot of these calculations, and make sure to ask questions if you need any help.